In this video, you are going to practice writing quadratic equations given the vertex and a point. So we're going to use vertex form. And from using vertex form, you want to understand the vertex is a point, hk, in the equation. And a point in the on the line of a quadratic function is x and y in your vertex form. So if you identify your vertex to be h and k, h is 2, k is 5, passing through a point 3, 7, this is x and y. So if I plug this into the vertex formula, y equals ax minus h squared plus k, out of the entire equation, I know what y is, it's 7. I do not know what it is. X is 3, h is 5, and h is 2 and k is 5. So substitute in the values you know. 7 equals, I don't know what a is, so I'm going to leave it as a. X minus h is going to be 3 minus 2 squared, and k is going to be 5 plus 5. So when I plug that in, I'm going to simplify and solve for a, and then go back and write this in vertex form. So when I simplify, 7 equals, 3 minus 2 is 1, so I'm going to have a times 1 squared plus 5. 1 squared is 1, so I'm just going to have 7 equals 1a, or just a, plus 5. If I need to solve for a, I need to get 5 to the other side of the equal sign, so I'm going to subtract 5 from both sides. So I should get 2 equals a. So I'm going to take this information of 2 equals a and write this in vertex form. So if I'm going to write this in vertex form to write the equation, I'm going to substitute in the values. So the formula is y equals a times x minus h squared plus k. I know h and k are the vertex, and I already solved for a, which is 2. So when I write my equation, I'm going to write it as y equals, substituting 2 for a, x minus h is 2, k is 5, so plus 5. This is the equation in vertex form for the quadratic function. Example number 2. We're going to follow the exact same process. So we want to identify the vertex to be h and k, and my point to be x and y. So in the equation, y equals ax minus h squared plus k, I'm going to substitute in what I know. So I know that y is 2. I don't know a, so I'm going to leave a as a variable. X minus h is going to be 9 minus 3 squared. 5 is k, so plus 5 on the outside. So if I simplify, I should get 2 equals, I still don't know what a is. I need to subtract first on the inside. So 9 minus 3 is 6. And then I will square it. So 6 squared is 36, so I should get 2 equals. Again, I don't know what a is, but I know that 6 squared is 36, so I'm going to put that in front of my variable. And then I still have plus 5. So this looks like an equation that I can solve for. So I'm going to move 5 over to the other side so that I can solve for a. Subtract 5 on both sides of the equal sign. And then I'm going to take 2 minus 5. You get negative 3 equals. I still have 36a on the right side. To undo multiplication, I need to divide by 36 on both sides. When I divide by 36 on both sides, a will simplify to negative 1 over 12 equals a. So if this is a, I'm going to take this information and I'm going to write this in vertex form using h and k from my problem. So if vertex form is y equals a times x minus h squared plus k, I'm going to substitute in what I know. I found A to be negative 1/12, so negative 1/12. I know that H is 5 and H is 3 and K is 5. So Y equals 1/12 X minus 3 squared plus 5. So when you plug this into the formula, you want to recognize when you plug in your H value, it's the opposite sign of what's given to you. When you plug in K, it's exactly the same sign on the outside of the parentheses. So this is your quadratic function in vertex form. In the very last example, we have our vertex to be negative 4, negative 8, and your point to be negative 2, negative 6. So this is my H and K, this is my X and Y. So I'm going to write the vertex form, Y equals AX minus H squared plus K, and I'm going to substitute in the values I know. Y is negative 6 equals, I don't know what A is, so I'm going to leave it as a variable, parentheses, X in my formula, in my point, is negative 2, H is negative 4. Be careful here. You're subtracting H. H is a negative 4, so you should have minus a negative 4. Then you're squaring all of that, plus K. K is negative 8, so I need to plug this in as a minus 8. So you need to be careful with your signs here. Now you're going to simplify. So negative 6 equals, I still don't know what A is, so leave it as A. Inside the parentheses, if I'm simplifying negative 2 minus a negative 4, this minus a negative changes to a plus. So negative 2 plus 4 is positive 2 squared, minus 8 on the outside. So negative 6 equals, I don't know A, so leave it as A. 2 squared is 4, so I have multiplied by 4, minus 8. Yes, you can have 4A, it's the same thing. So here I need to solve for A, so I need to move over this minus 8 by adding it to itself and adding it to the other side. It cancels on the left, so negative 6 plus 8 is positive 2. Positive 2 equals A times 4, or 4A. So now when I look at this problem, in order to solve for A, I need to undo multiplication, so I'm going to divide by 4 on each side of the equal sign, so 1/2 equals A. So if A is 1/2, I'm going to use this to substitute it back into my vertex form, and vertex form is going to be Y equals A times X minus H squared plus K. I know that A is 1/2. I know that H is negative 4, so when I plug in a negative 4, my sign will change. And I know that K is negative 8, so I'm going to have a minus 8 over here. So I'm just plugging this in so you can understand where these values are coming from. So Y equals 1/2, parentheses, X minus. When I have minus and negative, this will now change to a plus sign. All of this is squared, and then I have minus 8 on the outside. So this is the correct simplified form for the quadratic function written in vertex form using your vertex and a point. Now it's going to be your turn to try.